Hello and welcome back to video 11 for topic 3 networks. We're now going to explain how data is transmitted by packet switching. This is for the IB Diploma Programme in Computer Science. So still on topic 3, core syllabus, standard level and higher level. And we're right down at the bottom, the very last video for data transmission. Okay, before we move on to wireless networking. Okay, the objective is to understand the concept of packet switching. We're going to explain how data is divided into packets and transmitted across a network. We've done a little bit about this before. Explore the role of routers. Describe how routers determine the path of each packet through the network. Understand packet reassembly. Explain how packets are reassembled at the destination. Learn about undersea data cables. Now, it might be a little bit off tangent, but we're going to cover this one as well. Explore the role of undersea data cables in global data transmission. Okay, so we'll get started. Packet switching, what is it? Packet switching is a way of transmitting data in which a message is broken up into a number of packets. Okay, so a message from this computer, we've broken up into many different parts, and then it goes from node to node across the network until it gets reassembled at the other end. Each packet can then be sent independently, as you can see here, from start point to the end point. At the destination, the packets will need to be reassembled in their correct order, using the information sent in the header of the packet. In each stage of the transmission, there are nodes that contain a router. Okay, each router or router will determine which route the packet needs to take in order to reach its destination. This is why I call it a router, because of the word route. We don't call that a route. So anyway, that's another story. So here we go, packet switching. Let us now consider what happens when a photograph, for example, is sent from computer A to computer B. The photograph will be split up into a number of packets before it is sent. So the original message is green, blue, red. So the data packets take different routes to the destination. You can see them moving around the network now, moving from node to node. Very simple node structure here. There will be several possible routes for the packets between computer A, the sender, and computer B, the receiver. Each stage in the route contains a router or node. That's why I've called these nodes. A router receives a data packet and, based on the information in the header, decides where to send it next. So each router in the network determines the best path for the packet to take based on the destination address in the packet header. This process ensures efficient use of the network and reduces congestion. At the destination, at computer B, the packets are reassembled in the correct order to form the complete message. This is possible because each packet contains a sequence number in its header indicating its place in the overall message. Okay, so hopping and hop numbers. Here's my little rabbit. Sometimes it is possible for packets to get lost because they keep bouncing around. They might keep bouncing around from one node to another. Okay, one router to another, and never actually reaching the destination. Eventually the network will just grind to a halt as a number of lost packets mount up, clogging up the system. To overcome this, a method called hopping is used. A hop number is added to the header of each packet, and this number is reduced by 1 every time it leaves a router. So let's say it's got a hop number of 10. Basically, it can move between the nodes 10 times. It must get to the last node or to the end user on the 10th or less hop, otherwise it will disappear and a request will be sent back for a new packet to be sent. Okay? So what are the advantages of packet switching? There is no need to tie up a single communication line. Okay? During a crisis or disaster when the public telephone network might stop working, emails and texts can still be sent via packet switching by simple rerouting packets. It is relatively easy to expand packet usage. A high data transmission rate is possible. Devices of different speeds can communicate and work together. So the disadvantages though, packets can be lost and might need to be resent. This method is not so good for some types of data streams, e.g. real-time video streams can lose frames due to the way packets arrive out of sequence. There is a delay at the destination whilst the packets are being reordered. A little bit about global data transmission in terms of undersea cables, and these are critical for global data transmission, connecting continents and facilitating communications like video calls and streaming between countries and continents. You can see here, these are all the cables that are going under the sea. Okay, These cables stretch thousands and thousands of miles along the seafloor and are specifically designed to withstand harsh underwater weather conditions. Okay, so that's moving data around the world. So in conclusion, packet switching is a vital process in modern networking, allowing data to be efficiently transmitted across networks. By breaking data into packets and routing them independently, networks can avoid congestion and ensure reliable delivery. Routers play a crucial role in directing these packets along the best path, with the reassembly process at the destination ensuring the original message is accurately reconstructed. The vast networks of undersea cables further enhance global connectivity, making instantaneous communication across the globe possible. And finally, as always, we have 3 questions. Question 1, define what is meant by a packet in the context of data transmission, 2 marks. Question 2, describe how packet switching works in data transmission, 4 marks. And question 3, a big question, this one, explain the process of packet switching and discuss its importance in global communication with reference to undersea cables, okay, not Little Mermaid. So question 1, a packet is a small unit of data that is transmitted over a network. It contains both the actual data being sent and a header with information like the destination address and the sequence number to ensure it can reassemble correctly at the destination. Packet switching involves breaking a message into smaller packets that are sent independently across the network. Each packet is routed based on the destination address in its header. Along the way, routers direct the packets through various paths. Once all packets reach the destination, they are reassembled in the correct order to recreate the original message. There is usually some kind of error checking to make sure the same message has been received as the one that has been sent. Okay, but we don't need to worry about that. Question 3, the 8-mark question. Packet switching is a method where data is divided into smaller packets that are sent independently across the network. Each packet travels through different routes. We've already mentioned some of this before, and I realize that, based on the network's current traffic and conditions. Routers along the way determine the best path for each packet to reach its destination. Once all packets arrive, they are reassembled in the correct sequence to form the original message. This process is crucial for global communication, especially in systems like undersea cables that connect continents together. Undersea cables carry massive amounts of data across vast distances. Packet switching ensures efficient use of these cables by allowing multiple data streams to share the same path without waiting for one transmission to finish before starting another one. This system reduces delays, optimizes network traffic, and supports the vast and reliable global communications that we rely on today. Okay, that is it for this video. This is video 11 and the final part of this part of the topic. So I will see you next time for video 12. Thank you very much indeed. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.